Well, good evening, everyone. Welcome to the Institute for Climate, Energy and Disaster Solutions 5th Climate Update. I'd like to begin by acknowledging the traditional owners of the land on which we meet today, the Ngunnawal and Ngambri people, and pay my respects to their elders, past and present. I'd also like to acknowledge the traditional owners of country throughout Australia and their continuing connection to land, waters and communities. So today, as part of the Institute's 5th Climate Update, we are posing a question that you can see on the slide above. So that question is, if not now, when? So in addition to being the title of the 7th studio album of the American rock band Incubus, and a famous hit by Tracy Chapman, this is a question that has origins much earlier than that, formulated by Hillel the Elder sometime between 110 BCE and 10 CE. And these questions were very esoteric questions around the very being of individuals and where individuals and human beings sat within their communities. So what do we mean when we use this question today as the title of this update? Well, for me, I think it's a challenge to all of us to reflect on our responsibility towards ourselves and others, and also to think about the immediacy of the responses that are required. The evidence that you'll hear in this evening's presentations sends a clear message of the need for immediate and decisive action on climate change. So as MC, I've taken the liberty of extending the question, I think, today. I think what we should be thinking about is, if not now, when? If not us, who? So I'd like you all to think about that question as you listen to our speakers this afternoon. So I would like to introduce to the stage Shane Rattenbury, MLA. Shane Rattenbury is an elected member of the Kurrajong region and the leader of the ACT Greens. Shane was first elected to the ACT Legislative Assembly in 2008 and has served as Speaker and crossbench MLA, as well as holding various ministries, including Minister for Water, Energy and Emissions Reduction. As a long-time friend of ICEDS and no stranger to those interested in climate in the ACT. So please join me in welcoming Shane to the stage. Thank you.
Yuma Daro Nuna Daro Nunawal. Hello, this is Ngunnawal country, and it's lovely to join you here for this very important occasion to have the annual ANU Climate Update, which provides us an opportunity to explore the latest science. In a time of challenging headlines and anti-science sentiment, I thought I would try and start the afternoon with some good news. And I thought I would take you through the ACT's greenhouse gas inventory, which is the annual report released in the Territory, usually each December, that outlines where the ACT is up to on its emission projections. That report was released last December, and there we go. It was released last December, and it showed that the ACT has now reduced its emissions by 50% below 1990 levels. This is a really strong position for the Territory. It's actually quite inspiring to know that it is possible to take climate action in a rapid and effective timeline. Most of this reduction has come about through the ongoing 100% renewable electricity supply. And this graph shows the per capita emissions. You can see the significant drop there is where the 100% renewables particularly kicked in. And then we've continued to drop both with population growth, but also through emission reductions. One of the lines that I thought was most interesting in last year's inventory was to see a reduction in fossil gas use. This is where the Territory sits in the national context. But the issue of fossil fuel gas has been a really vexed one in Australia, and we have seen a big pushback from the gas industry. Anyone who watches TV is getting a steady supply of fossil fuel gas industry ads. The ACT fossil gas emissions were down 14% last year on the previous year, and they are in overall long-term decline. The ACT has taken a clear decision to phase out fossil fuel gas, the first jurisdiction in the country to do so, and to fully electrify the city is the intent of the territory. We are seeing more gas heating and hot water and cooking is being converted to electricity. What this information shows is that in the government clearly signalling the direction, the community has taken the hint. And I'm very encouraged by that. People are adopting the technology. They are, when they're updating their homes, when devices are breaking down, it is evident that people are taking the opportunity to become more efficient, and also the new rules that prohibit the connection of new gas across the city is starting to kick in. Again, this demonstrates that in taking clear policy decisions, setting long-term goals, one can both signal to the community where we're going and invite people to actually join the journey. There is variation in the annual gas data, colder and warmer winters, and you can see that in the numbers. They do go up and down a little, but this long-term trend, I think, is very encouraging. We also actually saw emissions associated with ground transport decrease by 3%. This was a more interesting development because being a car-based city, we've seen a steady growth in transport emissions, but also we saw a per capita reduction in this sector, and it's now lower than pre-pandemic levels. We did see quite a dip, of course, with the pandemic. I'm encouraged by this, and I think it also reflects the uptake of electric vehicles in the ACT starting to have an impact as well, and people, I think, having an appreciation of the necessity of driving more efficient vehicles. We did see aviation and waste emissions increase, and I think what I would say, well, is if all of this is for those who are into the science of these things, and I know there'll be a lot of people in this room, the greenhouse inventory is not a bad read. I know that sounds like a surprising thing to say, but it's actually full of some interesting insights into both the methodology of measurement, but also the complexities of the different sectors. And so I would encourage you, it's only 25 pages, it's not too bad, but it does show we're on track to meet our legislated targets in the ACT, which is based on the carbon budget that the Climate Council put together and recommended those targets for us. I was also invited tonight to briefly reflect on the importance of research in evidence-based policy in the context of an event in the ANU. And I think given current global circumstances, the importance of evidence-based policy cannot be underlined more heavily. Now, I could regale you with excellent examples of research done locally that's had a local real-world impact, and that includes the technological innovation that's being undertaken through our Renewable Energy Innovation Fund, which is helping startups and research here in Canberra take that next step. The research done to make the case to enable that gas transition, which meant that Treasury also got on board for it, which in any cabinet process is the great challenge. Our climate targets are based on excellent research by many locals, and the ANU partnership to monitor the impact of rental efficiency standards in the territory and how we monetise that and measure in really concrete ways what is great climate policy, but what is also important social policy. But rather than make the point that while research is a fundamental foundation to evidence-based policy, I want to actually underline the fact that it's not enough. We are in an era of alternative facts, mis- and disinformation, the removal of references to climate change on government websites, and tech bros overrunning democracy. And we are going to need much more than just good research. I think the extent and gravity of this problem has blindsided many people, but whilst to a certain extent we've seen it coming, I think many people have hoped that the pendulum will swing backwards towards sanity and reality at some point. I think it is clear now that we cannot just wait for the pendulum to swing back. We need to be much more deliberate in our efforts to combat this trend. I'm not sure that anybody has the right answers right now, and I know I certainly don't, but I do think there has to be an absolute insistence from scientists and policymakers to work from a basis of reality on the big issues, but also importantly on the small ones, because it is often the small areas where the waters are tested and the boundaries are pushed. If we acquiesce in parroting small lies or making small accommodations because we think they don't matter, or because we're trying to gain favour, we are softening ourselves up to parrot larger lies and make larger accommodations later on. Put simply, it is not the Gulf of America. So I will take this opportunity to underline the importance of research in evidence-based policy. Research can inspire, it can be a source of hope, it helps us find the best way to do things, but I think perhaps most importantly, it is fundamental to combating the alternative. Thank you very much and enjoy the evening.
Yes, thank you, Shane. That was very, very insightful. Thank you. It's my great pleasure now to introduce Professor Mark Howden. To many of you, he won't be a stranger, but for those of you who haven't been to a climate update before, Professor Mark Howden is the Director of the Institute for Climate, Energy and Disaster Solutions here at the Australian National University. He's also an honorary professor at Melbourne University. He's Vice Chair of the Intergovernmental Panel on Climate Change Working Group 2 and is Chair of the ACT Climate Change Council. And in the wee small hours of the morning, we often find Mark contributing to international advisory committees, both in the US and elsewhere. Now, Mark's undertaken research in climate variability and change and innovation and adoption issues over the last 36 years. And I've had the pleasure of being with Mark for probably just under half of those, Mark. So, yes. I think Mark has established very strong partnerships with many industry, community and policy groups in the research that he's done, and his research has focused on examining the intersection between climate, agriculture, food security, natural resources, ecosystems, biodiversity, energy, water, and the list goes on. He has been a consistent force, I think, for good in the IPCC process since 1991, and has contributed to the 2nd, 3rd, 4th, 5th, 6th, and 7th assessment reports. Mark has presented the ANU Climate Update since the inception, and today delivers the last update as the ICEDS Director. So please join me in warmly welcoming Mark to the stage.
Well, thanks, Steve, for that introduction. Thanks very much, Shane, for that presentation, which just shows and reinforces what a great place the ACT is to live. And I'd just like to thank everyone in the audience for being here tonight, but also all those people who are online for participating as well. And whilst I'm on the thank you side of things, there's a few people I really need to thank. There's many, I could keep going, but Aidan, the current Institute Manager, Claire, the previous Institute Manager, all of the staff, including Beck Colvin and Juliet, who have been here with me from the start of those institutes, and all of the staff who are contributing to today's event, doing an incredible job, often under somewhat difficult, stressful circumstances, given some of the dynamics that they have to face. So, and a particular thank you to my family who are over there, deserve a clap. For suffering through all of those evenings and mornings, etc., where I've got to do other things. So what I'm just going to cover, as Steve suggested or said, was just this question about if not now, when? And so it's a pretty fundamental question. As Steve said, it's got a long history, apart from going back to a couple of millennia. This was also raised by Theodore Roosevelt, who was the youngest ever president of the United States. He was 42 when he adopted the president, about half the age of the most recent incumbents. And that might tell you something about how things have changed in the world. But he said this, do something now. If not you, who's going to do that? If not here, where is it going to happen? And if not now, when? So really pretty fundamental questions about how do we start to act in ways which are consistent with our values. So what I'm going to do in this presentation is go through a whole series of little snippets of scientific information and ask this question and raise it in terms of our values, the things that generically we tend to acknowledge here in Australia. So one of the really critical slides that I always put up is an update of the Global Carbon Project, or Global Carbon Budget graph. Pep Canadell's in the audience. He's the leader of this fantastic organisation, and they produce this every year. So what this shows on the y-axis, the vertical axis, is carbon dioxide emissions in billions of tonnes a year and against different years. So this graph goes back to the 1990s, through the global financial crisis, through COVID. You can see those dips, temporary dips, and then into the recent couple of years. And you can see that in spite of the fact that we have the Paris Agreement that says we need to reduce greenhouse gas emissions, we've failed persistently to do that. So, and last year was no different. We increased greenhouse gas emissions by about 0.8% above the previous year. and that, of course, pumps carbon dioxide into the atmosphere, it accumulates in the atmosphere, and you end up increasing the carbon dioxide concentration in the atmosphere. So last year at its peak was around 427 parts per million versus around 280 pre-industrially. So we've increased carbon dioxide concentrations by more than 50%. So those concentrations last year went up by a record, about 2.9 parts per million globally, at Mauna Loa, 3.6. That's where the longest measurement record is. And those increases in carbon dioxide concentration are inconsistent with 1.5 degrees Celsius compatible pathways as identified by the IPCC and the science community. So we have to put to bed this idea that we're tracking okay and having some aspirational target of net zero by 2050 will somehow make us avoid net zero, 1.5 degrees. To do that, we have to take a lot more action, as I'll show you. At the same time, we've got record levels and emissions of carbon dioxide. We also have the same for methane, nitrous oxide and other greenhouse gases. So they're all at record levels. They're all heating up the atmosphere. And as a result, our emissions budget, our carbon budget that's consistent with 1.5 degrees is disappearing incredibly quickly. So the most recent sort of analysis that I've seen on this says that we have really only 4 years to go at current rates of emissions before we completely chew up our greenhouse gas emissions budget that's consistent with 1.5 degrees. So if we're serious about reducing our emissions to be consistent, this is the trajectory we have to go on, this dashed line. And for you, I don't know, but for me, I just don't think that's going to happen. And that commits us to really significant change in the future, notwithstanding how much we've experienced already. But weirdly, in spite of all of that evidence and the science there that people like Pep and others do so responsibly, we still have bizarre stuff going on in the world. And this headline for me just picks up some of this. You know, Antarctica's the new oil bonanza and Britain needs to fight off Argentina and other countries to get there first so they can be the first to pump that carbon dioxide up into the atmosphere. Like, what a mind-boggling sort of headline this is. What sort of bifurcation of the world do we live in where this can be feasible and accepted in our media as a statement of intention? So unsurprisingly, given we've known for 200 years that carbon dioxide is a greenhouse gas, it's not surprising our temperatures have gone up. Last year broke the previous record, which broke the previous record both by huge margins, and I'll show you what that looks like in a second. Last year was 1.5 degrees Celsius above pre-industrial levels, the first year above that 1.5 degree mark. And the last 10 years are the hottest 10 years on record. There is no let-up in this. There is no cool year that sort of takes the pressure off a little bit. It just keeps on coming. And that's exactly what we'd expect from climate change. If we look at this in a slightly different way, this is a graph from the Copernicus Climate Group in Europe. They've just laid out the same sort of information, but in a slightly different format. This is a month-by-month record of temperatures across the globe. Each of the little squiggly lines is a separate year. They're colour-coded down the bottom, they're the 1940s, and as they come up to the present, they colour change into the red colours. The sort of orangey colour at the top, or at least it looked orange on my screen before, is 2023, and the red one is 2024. And you can see that ever since around about June of 2023, we've had clear space between the hottest month and what's occurred in those 2 years. And that clear space is like a massive step change up in temperatures. It's not the usual incremental change that we normally expect. This is just a mind-boggling big step up in temperatures. It's like more than a decade of temperature increase in 2 years. And it's not really clear what's going on and driving those temperatures, which are quite extraordinary, like up at the North Pole, 22 degrees Celsius below normal. And the very fact that the science community can't actually divvy up all of the contributing factors adequately to explain what's going on should itself be a concern, because as it says, there's big unknowns here, bigger than we expected. And I commented on this last year. And what we're also seeing is increased levels of feedbacks. So, for example, the Arctic is now, instead of becoming an absorber of carbon dioxide, it's actually now an emitter of carbon dioxide. That was the NOAA's Arctic report, just released a few months back. And similarly, wildfires across the globe are generating increased carbon dioxide. So climate change is generating more fires, which pumps carbon dioxide and other greenhouse gases in the atmosphere, which generates more climate change, which generates more fires. So that's a feedback. And we're starting to see more and more of these coming into play. Now, given that the global temperature has increased, it's also important to look at how that relates to the experiences on the ground by people. And in particularly, it's very hot days or sometimes very cold nights that impact on us. So again, this is a graph from the Copernicus Climate Institute, and what it shows going back a couple of decades is the number of days per year that exceed particular temperature thresholds above 1 degree, 1.5 degrees, and 1.25 degrees. And you can see as you progress across that graph to the current time, the darker colours, the hotter temperatures, increase and increase quite dramatically. And in the most recent year, last year, 3/4 of days of the year were above 1.5 degrees, and the cooler days in the year were still above 1.25. So we're seeing this translate into really, really big, significant changes. Now, this also is resulting in significant changes in heatwave climatology, and people like Sarah Perkins-Kirkpatrick here at ANU are leading on analysing that. This is just one of many studies which shows that heat waves across the globe, they're coming more frequent, they're lasting longer, they're hotter, they're hurting more people, they're hurting our environment, they're hurting our economy. This is what's already happening. And at some stage, I think we have to ask that question, you know, how long will we let this keep on going? You know, at what point do we say, we need to get serious about this? At what point do we say, if not action now, when are we going to take action? If we look at progress towards 1.5 degrees, there's different ways of measuring 1.5 exceedance, and that's an area of active discussion in the science community. But for me, a really straightforward way is actually looking at the trends in temperatures. And again, that's what the Copernicus group in the EU has done in this graph. So they've got global temperatures put on that graph. They've done a linear regression through that and then extrapolated that out and seen where does that line intersect with the 1.5 degrees temperature increase. And that analysis shows that around about 2030 is when we'd, on a trend basis, we'd get to 1.5 degrees. Now, given that we're actually seeing a more than linear increase in temperatures, it makes more sense to actually put a curvilinear response into this. And if you actually put a best fit curve into that temperature graph, what you actually end up is we're likely to exceed 1.5 degrees on a trend basis next year. So if there was ever a message of urgency, this is it. This isn't 10 years away, this isn't 2050, this is next year that we're likely to hit 1.5 degrees. Now, another way of looking at that is, okay, how certain is the science? And Shane was talking about science certainty and how it can contribute but not dominate public discourse and decision making. So what I've just done here is actually lined up the different IPCC reports, going from top to bottom, the first to the sixth, and then basically put down there the certainty or uncertainty associated with human influence on global climate. So as you can see, in the first assessment report, it said that there was a discernible human influence. In the second assessment report, they were perhaps a little bit more cautious, and they said the balance of evidence says a discernible human influence. The third assessment report said it was likely due to humans. The fourth, very high confidence it was due to humans. The fifth, it was extreme confidence that humans were dominating the warming signal. And by the sixth, it was unequivocal that humans were warming the atmosphere, ocean and land. In other words, there is no uncertainty left. It is certain the influence that humans are having on the global climate. Now, I put this up because usually you think rationally in terms of decision making, the degree of certainty you have about something and the degree of significance of a decision play into how you actually make decisions. And as I put down at the bottom, some big decisions that we've made have been made with extraordinary low levels of certainty. So, for example, the second war in Iraq, which cost the US alone probably more than $3 trillion and may have killed more than 1 million people, was made on the basis of no credible evidence. That's what the post hoc assessments are of the evidence base. So we make huge calls with no or very little evidence, and yet we can't seem to make the same call when it comes to climate change, even though there is a huge amount of evidence and a huge amount of certainty. And not only certainty, but significance. Because this is global and because we can already start to see the fingerprints of impact, it's the combination of certainty and significance that should lead rationally to climate action. But it's not. Not to the extent that rational decision making would have. So at what point do we call this out? And we say, if this isn't certain enough, how much certainty do you need? What's the evidence base that tips you over into taking this seriously? Now, if you go and ask the experts, and The Guardian did this, and they said, what's your assessment of where we're going to end up in terms of climate change? And so they sort of did an analysis, and the results down the bottom there. So nearly 80% of those experts, and they were all IPCC authors, all legitimate climate scientists, etc., said that they were likely to see at least 2.5 degrees. Almost half said that we're likely to exceed 3 degrees, and only 6% said that we may actually stick to 1.5 degrees. So the vast majority of scientists have a pretty pessimistic view of climate change, that the action that we're seeing, the impact of science on decision making is such that we're not likely to avoid really significant climate change impacts. And when asked, about 3/4 of those scientists effectively blamed governments and lack of political will for the lack of action, and around about half, or 60%, said that it was also corporate interests, vested corporate interests. And I think that's probably a fair statement of sort of blame that needs to be laid. Now, one of the other things that came out of this survey was that younger scientists and female scientists were both much more pessimistic than those who are older or male. And that's, I think, really interesting, partly because those younger scientists are the ones who are going to inherit the mess that we leave, but also those younger scientists and female scientists often tend to be the ones who are most disempowered in decision-making processes, yet they're often the most affected. So there's increasing issues of equity, not just in the science domain, but right across climate change that need to be addressed. And inequity is a really poison. It's toxic for our society. We need to be reducing inequity, not increasing it. Now, if we look at sea level rise, we're all probably pretty aware of the consequences, impacts on coastal zones. We already see our beaches degrading in most parts of the world. Infrastructure at risk. We've got Barbara Norman in the audience, who's done a huge amount of work on this. It's down the front, and sort of leads a committee looking at sort of urban responses to climate change. We look at the Pacific Islands, and even under the best case climate scenarios, several of those Pacific Islands are going to disappear. We look at our Torres Strait Island. There's mud islands up in the Torres Strait that have already gone under because of sea level rise we've experienced. And one of those had the bramble chemalomus on it, and that animal is now extinct because that island has gone underwater. This is already happening. And so we sort of, in a sense, understand that, but there's a whole stack of other stuff that we probably don't necessarily see or hear about. So, for example, the assessments of future reductions in marine productivity and fishery productivity, particularly in the equatorial and tropical oceans, are for estimates of 30 and 40 and sometimes more % reduction in productivity. Huge potential impacts on the people who live there and depend on fishery as a resource. And yet, most recent studies suggested that those levels of impact were actually underestimated. We need to be really, really careful about the nature of the information and how we digest this. One of the really prevalent things now is that if you rely just on the global climate models pumped through an impact model, you almost always will significantly underestimate the rates of change and the risks of climate change. And that's just another example of that. If we look just off the coast here, there's headlines which say the Tasman Sea is now warm enough to actually support a tropical cyclone. 26.5 degrees is the temperature threshold. We won't get a tropical cyclone because of other climatological things such as wind shear. But nevertheless, that sort of is an indicator of how warm it is, how extraordinary the warmth is. And if you look at the coral reefs, which you know are highly sensitive to temperature, and we've got Penny Wensley in the audience who was looking at this with AIMS, the Australian Institute of Marine Science, it's effectively the impacts are literally off the charts. And the dial of impact, the Global Coral Monitor, they've actually had to add 3 more categories to deal with the emerging damage that they're observing in terms of coral reef, just in the same way we had to add new categories to our fire danger index. So these are things which are hitting our oceans as well as our land. And at what point do we say, let's hang on, this is really bad, we can't keep on going like this. Now, if you look at atmospheric water vapour, so this is the humidity in the atmosphere, what we've seen over that period in this graph from 1992 up to the present, about a 7% increase in water vapour in the atmosphere. Now, interestingly, that's exactly the number that was figured out 200 years ago as an equation called the Clausius-Clapeyron equation, figured out in 1834, which said for every degree Celsius increase, which is about the temperature increase from 92 to the present, you're going to increase water vapour by about 7% in the atmosphere. The problem is that water vapour is not evenly distributed, and the places that tend to have too much rainfall are getting more, and the places that don't have enough rainfall tend to be getting less, or at least less more variably. And really importantly, this does not translate to a 7% increase in rainfall intensity and hence flood risk. We actually see multiplying factors by short-term dynamics in the atmosphere that drive up that rainfall intensiveness really markedly. So typically these days, rainfall intensity might increase by 30 or 40% due to climate change, not 7%. And that's what's driving a lot of the big flood events that we're seeing across the globe and the storm damage that we're seeing across the globe. The increased water vapour, because increased water vapour translates to increased energy. And so we see, say, in the Queensland floods, there was an estimate, I don't know how reliable this one is, that it was like a 1 in 2,000 year event. What we're seeing right across the globe is what used to be a 1 in 100 year event is now a 1 in 20 year event. And what was a 1 in 20 year event is now a 1 in 5 year event. So we're seeing that frequency of really big events increase quite tremendously. And a lot of this material has actually been summarised really well by Albert van Dijk from Fenner School here at ANU, who puts out the Global Water Monitor report every year. So there's a really good resource if you want to follow up on this sort of information. Now, given that we're seeing these sorts of changes in rainfall and temperature across the globe, what I wanted to explore here was revisiting some graphs that I presented a few years back. So what I've done here is a really simple thing, and it's what I call the rainfall temperature operating envelope. So each of these dots on that graph is 1 year's data from the Bureau of Meteorology, and I've plotted it out temperature against rainfall for that year. So every dot is a year. Then what I've done is drawn a straight line, a linear regression between those to draw a relationship there, which you can see is quite strong. And I've put a hand-drawn ellipse around that to indicate the array of variability, how much it varies in that sample. Now, what you can see very simply is there's a strong relationship there between rainfall and temperature. Those years which are wetter are also colder. Those years which are drier are also hotter. And there's some really simple physics that goes on behind this. So if you've got a wet year, you've on average got a lot more cloud. That cloud reflects the sunlight back into the atmosphere before it hits the earth, and it doesn't warm the earth up. If you've got a wet land surface or wet vegetation, that when that water evaporates, it cools the land surface down just like sweat does when it evaporates from your skin. So there's a really simple set of physics that drives this relationship. Now, when I look at that pre-50s period, the 1950s to end of last century period and post-2000 years, what you can see, and they're all mapped out here, what you can see is that relationship between rainfall and temperature is robust across those three different periods. The slope of that line is identical across those three different periods. The physics operates equally in those periods. What has changed, though, is this. When you overlay those on top of each other, you see what's changed. And that envelope of variation that existed in 1950s, the pre-50s years, now has almost no variation with the envelope that existed post-2000 up to 2023. And you can see that little black dot there, which is last year, 2024. You can actually see that that's now started to emerge out of that envelope, that 20-year envelope. So we are in uncharted territory again, and increasingly uncharted. And if we look at what might happen over the next decades, scenarios for 2030 and 2050, you can see that 2024 is basically smack bang in the middle of a 2050 scenario. We don't have to wait. We don't have to have a time machine to do this. We're already in that scenario. And that, I think, is a really worrying thought, that we're moving so fast in terms of changes and impacts that we're actually already experiencing that 2050 sort of impact. And as I said before, in a lot of different domains, whether it's fire danger or fire season length, we're already often in 2050 or 2070 scenarios. So again, at what point do we actually say, we've got to take this seriously? This is really challenging for us, and it's impacting on a very fabric of our nation. Now, if we do a little bit of a diversion here into Southern Australian temperatures. So this is a graph, again, from the Bureau of Meteorology, and it shows temperatures since 1950 up to the present. Now, you'll see that the most recent year, 2024, is actually the second warmest on record. It was slightly cooler than 2019. And because it was only the second hottest year on record, it seemed to just slide past us in the media. There wasn't a lot of media coverage of this. We had the global sort of announcements of record temperatures, but when it came to Australia, it's just second hottest on record, don't worry about that, nothing to see here. And yet, because I've already shown you in those previous slides how that relationship between temperature and rainfall operates, we can actually do an adjustment. We can take out the rainfall signal from that temperature signal and look at what it would have been without having a relatively wet year last year. And the answer is, for Southern Australia, we would have been way hottest on record. Not by a little bit, but by a huge margin. Just like the global temperature last year was way hottest on record by a big margin. And this, I think, would have been newsworthy. And the difference between it being not newsworthy and newsworthy is simply some really basic analysis that brings in some of the basic drivers and variations of temperature and its relationship to rainfall. And if we look at the national temperatures, it's exactly the same picture. Top left is the raw data, the raw observed temperatures, and on the right, bottom right, it's the rainfall adjusted temperatures. And again, across the nation, if you take out that rainfall signal, we would have been the hottest on record. So we're not really being well served by some of our agencies which don't take into account some of these things and provide a slightly different and more nuanced view, which is more relevant to the people in Australia. Now, the people in Australia get climate change. I've put this particular slide up a few times, or the earlier versions of this, because I think it's really powerful. This is Lowy Institute report, and I note that Lowy Institute has a competing meeting with us tonight, but I'm putting this slide up anyway. And so what it shows, though, is a long history of asking the same question about climate change. And if you look at that, over the last several years, 90% of Australians say that they want more action on climate change. Around 60% want a lot more action, around about 30% want, somewhat more action, and only about 10% are prevaricating and not that buying into it. And so if you actually think about this, if we're not seeing adequate responses to climate change, given that these results are actually mirrored pretty closely by the global numbers, what level of buy-in by the public is needed to actually get us to take climate change seriously? If 90% isn't adequate, what do you have to go to? 95, 98, 99? What's the threshold at which we start taking this seriously? If 90% isn't enough, what is the level that is enough? And if you look at sort of in terms of policy, 3/4 of those surveyed support a more ambitious national emissions target. Even though we do have a much more ambitious target than we did previously, is that most people want more. And we're not seeing that in policy terms. And if we look at these figures from the National Greenhouse Gas Inventory, which I just downloaded, so they're as fresh as you can get, it might explain a little bit why. The top one is the greenhouse gas emissions from all sectors across the nation. The bottom one is all sectors minus or excluding the land sector. So that's the land clearing emissions. And you can see, if you look at the top, we have got a long-term decline in terms of emissions, but worryingly, the last 3 or 4 years is pretty much flatlining. And if you look at the bottom, though, is that in the last handful of years, that sort of flatline area, our emissions, if you take out land clearing, are only 1.8% below what they were in 2005, our benchmark year. So if you take out land clearing, we've made very, very little progress in terms of emission reduction. And so that should also tell you something about the difficulties in terms of policy, and why we're perhaps getting some pushback from some of the political parties in terms of greenhouse gas targets, emission targets. And something that people tend not to want to talk about is the interaction of population on this. Now, last year, the records show that Australia grew by 552,000 people net. You can't have an extra 500,000 people in the population and make the job of reducing greenhouse gas emissions easier. When you've got population growth of 2.1%, it just makes it hard to just tread water and keep your head above water, let alone make progress. We need to be more sophisticated in our dialogues, and we need to be asking that question, is the current policy mix adequate? If not, what more can we do so we can be more like the ACT? Thank you, Shane. Now, one of the things that really matters to all of us is what happens to our homes if we're lucky enough to own one. And what we see across the globe is that homes are at threat from climate change. The insurance industry records right across the globe are horrifying when you actually look at them. And the sort of amount and frequency of damage increases almost monotonically. But the information base on which that is based is fragmented. So for this particular slide, I went to the US and looked up NOAA's damage base. And what this shows is it's the frequency of events in the US which cause more than $1 billion worth of damage. So if you go back to the sort of 1980s, there might have been 3 events in a given year, each of which caused more than $1 billion of damage, CPI adjusted. So we're dealing apples with apples. But you can see the trajectory of that, particularly in recent times. It's not just going up linearly, it's going up exponentially. And the question I think you have to ask, if you're a homeowner and you're faced with cumulatively $1.5 trillion of loss in your primary asset, is at what level does this become unacceptable? Do we have to go up this curve so it's not just on average one of these mega events every fortnight, but does it have to be one of them every week before you take notice? You know, at what threshold do you actually start to take this seriously? And rationally, you'd think we'd already be at that point, because US and Australia and other countries are bleeding consistently due to climate change. We're all bleeding for climate change through our insurance premiums. But what's happening in the US is exactly the opposite. So under the new administration, the key weather forecaster, NOAA, National Ocean and Atmospheric Administration, and the key damage agency, FEMA, the Federal Emergency Management Authority, they're both basically looking like they're going to be axed. Huge amounts of staff, put on the chopping block, potential changes in mission, lots of intrusion in terms of the database by the DOGE operators. A huge threat to these agencies, which in a sense are frontline ways of managing this increasing risk. So the last of these sort of data slides, Jerry, thanks for the signal, is if you start thinking about just in terms of dollars, what's the information base on which we start to operate in terms of assessing the cost of climate change? So what I've done here is laid out by year of publication, 4 different publications which have done this assessment, what the percent reduction in GDP is per degree temperature increase. Now, remembering that most scientists think we're going to exceed 2.5 degrees, so you multiply these numbers by that type of thing. So, and what you can see is a tendency for increase. I haven't drawn a regression line because it's not sort of suitable to do that, but you can see that as those models have become more comprehensive, as they've become more complex and more realistic, those estimates of climate change damages increase. So the most recent analyses would indicate up to 20 to 25% damage on GDP per degree Celsius increase, which is really, really huge. And you might say, well, these are just one sort of method. Well, actually, there's multiple methods in those dots, and you can use a completely different method based on social cost of carbon to do a similar sort of assessment. And in that case, you're still in that 10 to 17% range of impact. Now, again, what is the point at which we say we don't want to go there? This is really problematic for us. We can't afford this sort of burden on our economy. It's much, much cheaper to reduce our greenhouse gas emissions than it is to bear these costs. That's what a rational decision maker would do, and yet we don't see much of that rationality at the moment. So again, it's that question, if not now, when do we actually generate the momentum for change that we need? And this isn't radicals saying these things. So the most recent of these reports actually came from the Actuaries Institute in the UK. Not exactly a hotbed of activism and radicalism, and yet the numbers that they come up with are really frightening. And they say very clearly that this is probably an underestimate because there's things that they haven't included in their assessment. Now, at the end of that, I actually think I do have to give you some hope, and I do have to say something positive. And so what I've done here is just put up a few sort of mnemonics that might be helpful, and noting that they're all science-backed. So you can talk with people like Beck Colvin and actually understand some of the science that goes on in some of these. But I'll just go through them. First up, don't delay, lead the way. What I've told you here is a story of urgency and significance. There is no time to muck around if we're to avoid really significant damages. And in terms of adjusting or dealing with that, we all can take a part. We can all be leaders, small and large. Don't delay, lead the way. Don't agonise, organise. There's lots and lots of things out there that you could do, some of which are better than others. You can agonise forever on this and have decision paralysis, or you could organise yourself, even if it's just to take small steps. And organising with other people helps you to take those steps by having groups and making commitments to other people to take action. Don't give up. It is really quite terrifying in some ways, but you can't give up because this is the world that our children and grandchildren are going to inherit. And so we need to speak up and step up. In doing that, we have to be respectful. We have to be respectful of the views of others, the situation of others, because we're not all in the same boat. We do need to understand that there's many different pathways and many different needs here. So we shouldn't berate each other. Even those who are sort of on the same side, we often see allies sniping at each other in unconstructive ways. So instead of berate, communicate, advocate, and motivate. Don't despair. Don't put your head down and try to just ignore it and hope that it'll go away, because it won't go away. That's what the evidence shows. And it will affect you. There is no place you can go on the earth which is not affected now by climate change, and in many cases affected significantly. So as a result, there's a huge amount of repair we can do because damage is already being done. There's lots of things we can do. And really importantly, action leads to hope. So that repair repairs us as well as our world. And the last one is, don't just offset. And I'm not talking about carbon emissions and safeguard mechanisms here. I'm talking about don't offset, reset. Minor incremental changes are not enough now. We have to think about more transformational changes. We have to think about innovation in the ways we do things, not just science, but in our politics. And we have to think about imagination. So what is the world that we want? And how, once we've actually decided on that and had that discussion, at least we can start heading there. But at the moment, I see an Australia that is rudderless in terms of vision for what we actually want here in Australia. So just to finish, just going back to the start, if not you, who? If not here, where? If not now.
Questions, sir?
Rod Holsgrove. Very briefly, by background, I was at Rio Earth Summit when I stood by Ros Kelly, the Environment Minister, when she signed the Climate Change Convention 32 years ago. And it's hard to feel hope sometimes but we obviously have to keep going. What I'd like to ask Mark is, with this rudderless government, what key things would you suggest that the national government do, nationally and internationally, in this really extreme situation? Are there a few top things that they're not doing and should be doing?
Thanks, Rod. So far be it from me to tell governments what to do, but what the economists say is almost to a person is that the most efficient, economically efficient way of dealing with greenhouse gas emissions is through a price on carbon, a price on greenhouse gas emissions. And now we know that this is a very patchy history in Australia, politically sort of a minefield, but if there was a government that was brave, that was actually looking at doing something really constructive, it's going down that pathway. I think at the moment we have a huge gap in terms of the climate adaptation domain. So there is a national adaptation plan which has gone out for comment, but it's back with the government. But we need not to only have a plan, but we actually need to put it in action. So there needs to be resources and long-term commitment, and preferably bipartisan commitment or tripartisan commitment on that. And so we need to be taking that seriously, that we're seeing really significant impacts already, and we need to get our act together in terms of managing those. So those are a couple of things there, but generally speaking, I think a lot of the policies we're seeing both at federal and state level are pretty sensible, and we've put up a whole series of really good institutions like ARENA and CEFC, but there's continuing pressure to wind those back. And so as the best can happen, locking those in so they're immune from future tinkering by governments who do want to do that winding back, I think is also important.
Next question, Evelina, from the online crowd. Sorry.
So Mark, on your last slide, you talked a little bit about the rationality of decision makers, and I'm drawing on a few different questions from the online audience here. There's some reflection about how companies don't want to necessarily invest in decarbonisation because of a lack of economic sense that they see, and the challenges of the counterfactual, where we've seen the GDP continue to grow despite a degree of warming already that's happened. So the question is what you think about the impact of measuring the impacts of climate change in a per capita basis, maybe on a more global scale, looking at emissions per capita and maybe the costs per capita, and recognizing that it's a challenge that impacts all people equally.
Thanks, Evelina, and thanks whoever asked that online. There's a couple of different elements there, and I'll just deal with them briefly. So in terms of companies lining up to take green action, very soon, right across the globe, at least in the developed countries, there's going to be a requirement for sustainability accounting. So the accounting sustainability standards are already here in Australia, and increasingly they'll be needed to be abided by companies, with that going down from the biggest companies gradually down the chain. And that effectively makes climate reporting mandatory, and that's a start. The thing, though, is that companies can pay lip service to this. If there isn't significant shareholder pressure, they can report in a way that doesn't really say much. But the driver, I think, for change is increasingly at both company level and at national level, is the evidence that that old sort of story is that you can either be broke or and green, or you can be profitable but red, is actually wrong. Is that the countries that have actually done best in terms of emission reduction are also the countries that are doing best economically, and vice versa. So those sort of you can be prosperous or you can be sustainable. Those arguments no longer exist. Smart companies, smart people, smart countries are moving on this in a way that ticks both boxes, and they're often happier as a result of that, and they're certainly more in charge of their own future. And in terms of the global side of things, these arguments have been around for decades and decades about global equity, and there is no answer to this, because different groups will have very, very different views depending on, say, historical emissions versus present-day emissions. How do you do a fair distribution of slicing of emissions? But one of the conclusions is of most ethicists and philosophers who look at this is that pretty much all of the developed world has already done their dough in terms of greenhouse gas emissions. They should go to zero, and the developing countries should take what share is left in terms of carbon budgets.
Thanks, Mark. We'll stay on that side. If you'd like to ask your question.
Yes, I don't know whether Professor Howden wants to answer this on the national scale or Shane Rattenbury at the ACT level, but I looked at the greenhouse gas inventory for 23-24, and although the vehicle emissions are slightly going down, transport emissions are slightly going down, they're sort of bouncing around. But what I noticed, that petrol consumption is going down, but diesel has doubled in the last decade in the ACT, and I looked at the national figures, and there was a significant increase in diesel use nationally. What I wasn't able to find out was whether that was mainly due to individual family car use, or whether that was commercial vehicles. And so is there a possible solution there in addressing how to reduce diesel emissions, and how could that be done?
I can't speak for the ACT, but if you go back a little way, diesel cars were more efficient in terms of litres per 100 kilometres, and so you could significantly reduce your consumption in terms of litres. The problem is diesel actually produces more emissions per litre, and so oftentimes they were as dirty in terms of emissions as a petrol-driven car. And so as diesel's sort of kept fairly high in price, people are backing away. So at the moment it's whatever, $2.10 a litre or $2.06 a litre. Petrol's cheaper than that. What you're starting to see, I think, in the car fleets is people not necessarily wanting to go full EV, but they're actually wanting to cut down on their petrol consumption, partly for cost reasons. And so they're moving to hybrids, not necessarily moving all the way to an EV. But a hybrid still, obviously still emits, but it's a lot lower emissions than a non-hybrid equivalent vehicle. So I think what we would see is we'll see, waves of change depending on the economic and other circumstances that people find themselves in. And the policies in the ACT which incentivise people to go to more efficient cars have been in for quite some years, like higher registration fees for more fuel inefficient cars. So there are signals there.
Thanks, Mark. We are running out of time, so we probably have one last opportunity to ask a question from the online audience. Just before you ask that question, Evelina, I would encourage everyone, if you do have a question, you haven't managed to ask your question today, please send us an email to our Institute email. We will be doing an analysis of a range of questions that have been posed both in the online chat and raised in the audience today, and that will be presented as part of a release that we have, a regular release from the Institute. Evelina, your question.
Let's end on another optimistic note. Mark, the online audience is interested to hear some more of your thoughts on transformational change. What political and economic norms do we really need to break? And advice for young people in particular working on climate change in their home countries outside of Australia, so not necessarily just in the Australian context. What can they do to drive transformative change beyond individual action?
Thanks, Evelina. Great question. So in terms of transformational change, there's no set definition for what becomes transformational, what isn't. But generally speaking, it's something which changes the function or the dynamics of a business or an operation or something in a significant way. And the challenges with transformation is that you can have a lot of risk associated with moving from where things are to where things could be, and it's often more complex and more costly than sort of more incremental changes. So there's a bit of risk aversion that can come into people. We also see that the information base on transformational change is often very low, and so we haven't got the sort of same information base that we do with more incremental change, where you know the system fairly well, and so tweaking it, you get a fairly predictable outcome. So there's a various array of informational and similar barriers. But there's also social barriers. And so going back to 1973, there's a great paper called The Strength of Weak Ties by Granovetter. And their proposition was for large-scale changes, weak social ties are really facilitating, because it stops social norms from holding people back. So when you've got really strong ties and strong social norms, people, if you try to do something too different, you get pushback from the group around you, and so there's strong social pushback. And that hypothesis has been demonstrated in many different circumstances, and I think it's an important one in terms of transformational. Because once you start doing more transformational things, people say, oh, that can't work here, that's not the way we do things around here, that person's loopy, how can they possibly do that sort of change? And so oftentimes there are quite significant social barriers which you need to overcome by leadership, and that leadership isn't necessarily just the actors involved, but it often is at higher levels, which legitimises that type of change.
Thank you, Mark. I'm sorry that we have to draw the Q&A session to a close, because we do have one other person who's going to be presenting today. So, Mark, before you go, I would like to ask everyone if you could join me in being upstanding and thank Mark for his contribution. Thank you very much. Well, thank you for that. It is my pleasure now to introduce Hannah Vardy. Now, Hannah Vardy is a student here at ANU, and she's studying climate science, molecular biology and law. And she's been coordinating youth climate action groups for several years and is a member of the Duty of Care campaign, which is aiming to enshrine a duty of care on climate change in Australian law. So, Hannah, I'd like to welcome you to the stage, please.
Good evening, and thank you, Steve, for that generous introduction, and for ICEDS for inviting me to speak here tonight. My name is Hannah, and for the past 18 months, I've been working alongside 3 fellow ANU students on the Duty of Care campaign. Our efforts have helped build nationwide support for legislation that enshrines the principle that governments have a legal responsibility to protect children and future generations from climate harm. Before going any further, I'd like to thank Mark for his remarks and reflect on his time here at the ANU. Last week, I turned 21. This means that Mark has led ICEDS and its predecessor, the ANU Climate Change Institute, since I was in primary school. Hopefully, without making anyone feel too old, this underscores Mark's incredible contribution to the ANU. His tenure is remarkable not just for its duration, but for the transformational impact of his leadership on climate science, research and policy at the local, national and international level. On a more personal note, I'm so grateful for the time, expertise and advice that Mark has lent to myself and so many other students starting their careers in this space. I'm sure I speak for the room in saying that he'll be sorely missed at ICEDS and that we wish him the very best in his next steps. In wrapping up this evening's event, I wanted to translate some of the figures and graphs that Mark presented into their more personal meaning for my life and the lives of those in generations to come. We know that the health of a child born today will be defined by climate change. The climate disasters that have occurred just over the past 2 decades illustrate this. The last 10 years of my life have been the 10 hottest on record. A little over a year before I was born, in January 2003, devastating bushfires hit Canberra, burning over 2/3 of the ACT. Then, on my 5th birthday in 2009, the Black Saturday bushfires hit Victoria, whipped up by a perfect storm of heat, wind and drought. And then, the Black Summer bushfires in 2019. All of us here tonight have a story about the devastating impact those fires had. And then, in 2022, as I turned 18, floods devastated parts of northern New South Wales, inundating the Mullumbimby home that my dad grew up in. It is highly likely that none of these events would have reached the scale, the magnitude, or the ferocity that they did without climate change. I don't share these impacts to cause only despair, anger, or grief, although these are all completely justified, especially in the face of the present and the future that Mark just outlined. I share them to highlight how climate change has and will continue to shape the world that my generation will inherit. But there are also glimmers of hope amidst all this bleakness. So, rewinding a little, let's go back to 1983, which happens to be 21 years before I was born. Pioneering research by a team that included ANU's own Professor Andrew Blakers resulted in a quantum leap in the efficiency of solar panels. Once considered viable only for satellite technology, solar has now exceeded all expectations and has been rapidly deployed worldwide. In 2004, the year I was born, it took a year to add 1 gigawatt of solar power capacity globally. It now takes just a single day and is projected to take only an hour by the time I'm 30. In 2019, we witnessed hundreds of thousands of people, including myself and my peers, take to the streets across the country in the school strikes for climate, the biggest protests in this country's history. This was such an inspiring moment for so many of us. We'd found thousands of people that cared about a safe and livable climate just as much as we did, and a way to galvanise our frustration over a lack of climate action into a fight for change. While it seems that the climate wars in Australia aren't yet over, Labor's 22 election win was largely driven by concerns over climate, and we've seen massive investments in solar, wind and batteries ever since. We've seen record-breaking investments in electrification in the US, a pledge to end deforestation in the Amazon by 2030, and projections that the ozone hole over the Antarctic will close years earlier than initially expected. And we've seen a steep rise in successful youth-led court cases around the world over the past few years, holding governments to account for their inaction to safeguard our future. This has included a court case here in Australia, led by Anjali Sharma, that sparked the Duty of Care campaign, and we're continuing this fight to this day. We know that we aren't moving at nearly the pace we must to stay below even 2 degrees of warming. But we also know that the next generation of leaders is bold and bright and ready to take on this challenge. As we talk about the next generation of leaders, we can't ignore the fact that we are heading into federal election season. So, a parting message. During the next few months, find a way to escape your echo chambers and make climate a priority to those across the political spectrum. It is so crucially important that the long-term impacts of climate change and the enormous opportunity that Australia has in addressing it aren't drowned out in the noise. I'd like to end by looking forward. By 2050, I'll be 46 years old, and right now the path to net zero looks uncertain at best. But we all have the power to chart a better course, whether by speaking up in our local communities, advocating for policy reform, or making choices in our own lives that ripple far beyond what we could imagine. The decisions made today by everybody in this room, in whatever capacity we hold, will shape the world that we are leaving behind. My hope, one that I must hold on to, is that these decisions are made with the best interests of our future and that of the generations to come. Thank you.
Thank you, Hannah.